Welcome to the 7th and final part of our series NFT tickets for your event. Let's go straight to our verify.js file. We will create our verify function, which for now will only display on the screen a text that we will take from a variable step. Let's export our verify function, and let's start by taking the name of our route order to read and write to the database. We do this in the same way we did for the access route, but eliminating the verify route in this case, and of course eliminating the not allowed characters. Now we can set the reference to our database. Remember to import the VB object as we have been doing. The first thing that happens when loading this page is that we change the action field to scanned. This notifies the base application that a verification process has started. We use the useEffect hook to change the action field of our database to scanned using the update function from the Firebase database library. We must import useEffect from React and the update function from Firebase database. This function will send the reference to the database and an object with the field we are going to update and the new value. The information that our verify route will display on the screen will depend on the process that is being executed. For this, we need to use the setState hook to declare our step state variable and its respective function to update it. In the first rendering of our page, we will place connecting in our step variable. We are going to place a call to verify ticket function that will receive the reference of the database and our step function. We will create this function in a file called blockchain.js, and we will import it in advance in this way. We create our blockchain.js file, and now we will write all the code to connect the Phantom wallet and verify the position and status of the NFTs that this wallet holds. We will create our verify ticket function that will receive the reference to the database and the function to update the text that will be displayed in the verify route. And here we start with the verification process. First, we determine if the browser has access to the Phantom wallet. If it does not find Phantom, we update the action field to no Phantom and the step text to please connect from the Phantom app and interrupt the function. Remember to import the update function from Firebase database library. We will do something similar to determine if the Ethereum network is set up in the following way. If it does not have access to Ethereum, it changes the action in the database, the info to be displayed, and interrupts the function. If everything goes well, we can now start the process of authorizing access to the wallet in a similar way to how we did in the 6th part of the series. We make a request in provider with the method ETH request account. We add a then with the appropriate error handling, and if permission is obtained, we will receive a function with all the account associated with the wallet and saves the first wallet from the obtained array in the variable client accounts. This variable must be declared beforehand properly. Now we change the value of our action field to connected, and the account field we set with the user wallet. We change the step text to indicate that there is a connection, and we are now verifying the NFTs. Now we need to make a request to change to the Mumbai network using the object we will call QuickNodeRPC_config. We are going to declare this object here at the top, and it should have your own QuickNodeRPC for the Mumbai Polygon testnet in the value of RPC URLs. If you have not yet created it, we invite you to do so on the quicknode.com page. Here we will also access the then method with the respective error handling, and if the process is successful, we will save our provider configure for the Mumbai testnet in a variable Phantom provider EVM that we must declare at the beginning of the code. Now we will call a verification function to which we will send the client's wallet, the reference to the database, and the function to change the text on the screen. We create the verification function that at first should get the ID of some valid NFT for this wallet, and then it will continue the process. For this, we will create the getWalletNFT function, which will receive the client's wallet. This function will look for a valid ID for an NFT from our collection within the wallet, and for this, it will need an instance of the NFT contract that it will get through a getInstanceContract function that we will also create next. Since this function will only need to create this instance once, we are going to verify if there is a global contract NFT variable instantiated. This variable we will declare at the beginning of all the code. If it has not been instantiated yet, we start the process. We create a Web3 variable as a new instance of the Web3 library using the Phantom provider for the Ethereum virtual machine that we obtained earlier. Let's not forget to install and import the Web3 library. Now we create our contract instance and save it in the global contract NFT variable that we have already declared. To create this contract instance, we use the ETH method of our variable. This function needs to receive the contract address and the API code. Remember that the address should be that of the last modified contract that we deployed in the previous video. And we should create the contract abi.json file with the corresponding code that we can obtain on the Mumbai testnet page, as we have been doing so far. Remember to import our API contract.json file. We return the instantiated contract. Back to the getWalletNFT function, we can access the contracts method that we have obtained, and we will access the getIDOwnedByAccount method that we created in the previous video in our ERC1155 contract, which will return the ID of the first NFT of the deployed collection that it finds for that wallet. Remember that this function receives the index, which will be 0, and the wallet address, and will return the NFT ID, or 0, in case it does not find a valid NFT. In our verification function, now that we have the ID or the value 0, as the case may be, we are going to perform the following procedure. If the obtained ID is not 0, then the new action will be possessed, and the text ticket found, verifying validity. If it is 0, the action will now be denied, and the text, no valid tickets were found. Now it's up to us verify, in case we have found valid ticket, whether it has already been used or not. For this, we have the isVerify function in the contract. Then we will call an isVerify function that receives the NFT ID. We will create this function, and it will need a contract instance. Our isVerify function will access the getVerify method that is available to the contract. This method receives the index 0 and the ID to verify, and will return false if the NFT ID has not yet been used, and true if it has already been used. Now we have to verify if our constant isB turns out to be false, which will mean that we have found a valid ticket that has not yet been used, and we give access to the event to the holder of that wallet. Otherwise, the corresponding action would be already used, and we display the information that the ticket has already been used and deny access to the event. Now, to test the functionality of our app so far, we must deploy it at an address with SSL, and we will do what we have done so far, which is to create a new repository on Github to deploy with Vercel. We copy the address of the new repository, git init, we add the new address as origin, git add, git commit, and push. Now, in Vercel, create new project. We select our repository and deploy. We access the page, and in our Firebase console, we see how a new collection has been created with the new address of the app. This will be the collection with which we will work from the Phantom app. Every time we make a push and Vercel deploys it with another address, the app will automatically create a new collection. We are missing an important step, which would be to set the setVerify property of each NFT that has been used to give access to the event to true. Since we will be automatically signing transactions on the blockchain, it would be best to create a separate Node.js server to handle this function, and which we will access from our base app. To create our simple server, we open another Visual Studio Code window in a folder of our choice and run npm init. We use the default value and create the index.js file. We are also going to add this line of code in the package.js. We create the following constant that will require the library of the same name: Express, Course, Web3, and FS. We install all these libraries. We declare the constant app in this way and the port. We enable these two middlewares. The first one to avoid rejection of origin problems, and the second one to make sure we parse the information correctly. Now we are going to instantiate all the information we need to interact with the contract. We will need to have access to the private key of the wallet that deployed the contract. For this we create a .secret file and put our private key here. We will also create an ABI contract file to which we will put the ABI in, exactly the same as it is in our React application. We also copy the contract address from our React app. And we will create a QuickNode RPC variable with your QuickNode RPC. Remember that you must create your own QuickNode RPC to use it in all the processes of this tutorial. Now we are going to declare a constant Web3 through a new provider using our QuickNode RPC. Now we are going to create a contract instance in the following way, with the ABI contract and the address as parameter. This server for the moment will only have one post route, set verify, and it will be listening on the port we have declared as follows. Our setVerify route expects to receive in the request body an object with the NFT ID and the true or false flag, which for our case will always be true, as for now we will use it to establish that the NFT has already been used. We will create a transaction object with the parameter. From, we extract our account by passing the private key to the private key 2 account function as seen on the screen. 2. The contract address, the following gas limit and gas price parameters. And in the data parameter, we are going to pass the setVerify function available for our contract, with the parameter 0 as index, the ID that we have received in the request body, converted to integer, and our flag. In addition, we must call the encode ABI function that will encode the parameters as appropriate in this type of transaction. We must also set the gas provider parameter as a new HTTP provider with our QuickNode RPC. We only need to sign the transaction in the following way, using our transaction object and the private key, and the result we save in the constant signTX, and finally send the signed transaction to the blockchain in this way, which will generate a receipt and we will send it as a response. To deploy our server, we will use a service called render.conf. But before, we must create a new repository and carry out the entire process to upload our code to GitHub. On the render.conf page, we log in with GitHub and go to New. We select Web Service and locate our repository. Then we put a name and we are going to create a web service. And this is how we will deploy our server. Back to our app after determining that the isVerify was false. We will call a setVerify function with the ID and the true flag. And we write this function that receives the ID and the flag, and we will make a fetch to the server address with the method parameter in post, the corresponding headers, and in the body we will send an object parsed with the ID and the flag, which the server expects to receive. We handle the response and errors. Git add, git commit, and push. And now we finally have our app ready. We can connect from the Phantom and we see how the app gives us access. But if we try to do it again, it will tell us that the ticket has already been used since the property has been changed to true from the server. It has been a great pleasure to have shown you all this information, and we hope it has been useful to you. Leave us in the comments if you have any questions, or if you have any suggestions on how to improve this solution or what other idea we could implement. Until the next time.